Welcome to FYI, the Four-Year Innovation Podcast. This show offers an intellectual discussion on technologically enabled disruption, because investing in innovation starts with understanding it. To learn more, visit arc-invest.com.
ARK Invest is a registered investment advisor focused on investing in disruptive innovation. This podcast is for informational purposes only and should not be relied upon as a basis for investment decisions. It does not constitute, either explicitly or implicitly, any provision of services or products by ARK. All statements made regarding companies or securities are strictly beliefs and points of view held by ARK or podcast guests, and are not endorsements or recommendations by ARK to buy, sell, or hold any security. Clients of ARK Investment Management may maintain positions in the securities discussed in this podcast.
From ARK Invest, this is FYI, the Four-Year Innovation Podcast. We've got a great show for you today. Today, Charlie Roberts and I are speaking to Stephen Balaban, who is the founder and CEO of Lambda. We are investors in Lambda in our venture strategy. Frank, what kind of part of the value chain does Lambda occupy, and what are our expectations for AI hardware investment over time?
Yeah, so Lambda is at its heart a neo cloud, or a cloud computing company focused on AI specific infrastructure. And so if you think of the value chain or the stack in AI, you have the hardware makers like Nvidia and AMD that I guess design chips that are manufactured by TSMC. You have the companies that are buying those chips and making them useful to AI software companies. And so Lambda sits in this bucket here. It's the bucket that AWS, Google Cloud, Azure sit in, as well as CoreWeave would be the primary neo cloud competitor that has just entered the public markets. And then their customers are big and small AI companies alike that are training and deploying models to drive knowledge worker productivity. And that's when we think about AI use cases. Well, there are many across different embodiments or different modalities. When we look at knowledge worker productivity, we estimate there's about 1 billion knowledge workers in the world today that get paid about $30,000 US dollars a year on average, which is about, if you multiply those two together, a $30 trillion global spend on knowledge work per year across the economy. And we think that through the productivity that AI can drive this installed base of knowledge workers, you could offset forward labor spend with AI spend to the tune of $7 trillion by 2030. And if you look historically at the amount of hardware needed to power traditional software and cloud computing software, we've seen the amount of hardware pulled in to support software demand going down over time from 30 to 40% down to about 20-25% as of 2022, pre-ChatGPT. And so our base case expectation is that by 2030, we're at the same efficiency level, and you have 20% of that $7 trillion roughly pulling hardware demand per year to support it, which would be about $1.5 trillion of expected data center system sales by 2030.
So $1.5 trillion in kind of like AI buildings and compute and stuff per year invested by 2030 is our base case expectation. And Lambda is, presumably providing, or basically the implementation of this. They're effectively upfronting the capital, building the buildings, installing the GPUs, getting them to run really well on behalf of their customers, the likes of which could be OpenAI or kind of these foundation model companies that are training these AI systems.
Yeah, I mean, actually, now that I think about it, the data center system sales is their expense, their CapEx investment, right? And so they're presumably operating at a margin on top of that. We know AWS's operating margin is around high 30s right now. So picture that as like the long-term end state when you hit max efficiency. You can be a 30 to 40% operating margin company, so that their revenue would be bigger than this 1 year of CapEx.
Sure. And so then just thinking about it from continuing the back of the envelope, if I have 1.5 trillion in kind of like new data center investments in a year, and kind of, it's occupied by infrastructure as a service providers like Lambda, you get 30% of that into operating earnings. So that's $450 billion in operating earnings. I don't know what you pay for that, but 10 to 20 times, that suggests, anywhere from $4.5 trillion to $9 trillion in kind of like infrastructure as a service providers by 2030. Does that math check out?
I think so. I mean, in short, it's a big opportunity.
Right. I mean, generally, the way we think about the entire kind of AI stack is you could have 90-ish trillion dollars or in the close to, $100 trillion in market cap attributable, of which a meaningful portion will accrue to these infrastructure as a service providers. Why would people go, and I actually asked Stephen this in the interview, but I'm curious as to your opinion, why on earth would I, a global business, turn into a smaller startup to provide my GPU infrastructure when I could turn to AWS or GCP, has data centers everywhere, and have them provide me with my AI training?
I guess kind of two things that are interrelated. But one is operating cloud services in and of itself is not trivial. If it was easily commoditized and anybody could do it, you wouldn't have kind of this market of 3 or 5 really big cloud companies that can do it well with healthy margins, and then a long tail that don't do it as well. We have AWS, Azure, GCP really dominating global traditional cloud computing, and now all with significant cash flow coming off of them. And so that business, I think, has been more defensible than people thought when AWS launched in 2006, I believe. And part of the reason why is because they don't just buy servers and rent them out. They do value-added services on top. There's just the economies of scale of being able to purchase and operate and deploy in very large volumes. There's also tightly coupling additional services on top that developers increasingly want to plug into because it makes their lives easier. So it's easier to one degree to not have to rack and stack servers yourself in a private data center that you need to acquire and monitor and maintain. It's even better if you can automatically scale up and load balance across those servers. And that's kind of where you get into this like platform as a service offering, where all of the clouds now probably make as much or more revenue from the platform level offerings than people going and just renting bare metal compute from them. So there's a big business and economies of scale that happen just from being good at operating a cloud. And then the second of why a neo cloud should exist, that's kind of why clouds can exist and have margins in general. Why a neocloud can exist is because it's also not trivial to stand up AI infrastructure in particular, because it is different infrastructure from traditional computing, where you now have Nvidia accelerated servers versus Intel and AMD dominated CPU compute servers. They are much more power dense. They require now on the high end of Nvidia Blackwell an entirely new rack design. There's a different network topology. And there's a whole different way that you monitor for observability, because instead of having, cloud computing had shared use servers, where you're getting more utilization out of one server because you can have a very powerful server that potentially hundreds of thousands or tens of thousands of users can consume at one time, which is the efficiency that cloud brought, like multi-tenant use of the server. In AI, you almost flip that in a way. It's slightly different, but you have one LLM that's running or being trained across tens of thousands of GPUs. So now you have kind of like one use case distributed across a lot of infrastructure, which is different from traditional computing and traditional cloud computing. And so there's room for players like a Lambda Labs to specialize in this domain, to go into the AI version of platform as a service offerings, and to be faster to market than these well-run but very large cloud incumbents.
Yeah, it's interesting how across the stack, it's like AI just requires a different set of processes and business optimizations than traditional software. And I think that's part of, like, even not just at the infrastructure level, but just the way companies take on and deploy AI software has to be much more like human capital management, like humans which do random stuff and accidentally make mistakes. And that's more how AI software operates. And, similarly, there's just like a different set of procedures that are required to support the development of this software. And so I think it's actually reasonable to assert that across all levels of the value chain, there's a disruptive potential to how AI gets deployed here. And you could see it initially in, even Nvidia kind of overtaking and supplanting Intel as the most important computer chip provider in the world. That was something that people argued couldn't happen, as when we started Arc. It's happening at the infrastructure as a service level. We think it's probably happening at the platform as a service level. And ultimately, it could be, a shakeup of the entire fundamental operating system of how we interact with the machines that are going to be increasingly entangled in our lives. So I want to cover a few things that are not covered in your forecast of 1.5 trillion by 2030. That's just against enterprise AI. So any robotics, robotaxi, genomics demand for AI compute is not effectively measured in that forecast. And the forecast implies that we're still going to pay out some $10 trillion in incremental knowledge worker wages over the next 10 years, rather than kind of more aggressively investing in kind of AI software to make the existing knowledge workforce, more productive. And, at least on the margin, it seems like the evidence is, if you look at kind of software engineering roles, that people are happy to invest in these kind of employee multiplication tools, rather than necessarily putting on more heads. I guess it remains to be seen.
I agree. So the one thing I would say on what's not covered is that if you're looking at the historic trend of data center system sales versus software investment, there was presumably uncovered stuff in that analysis as well, as in every company that's using a general software product for a specific vertical. So there's some amount of that based on how we're doing this included, but I agree.
Yeah.
In spirit.
I mean, ultimately, my belief is that even we who are, call it, more willing to kind of like dimension the size of a space that's uncertain. I think there is a natural human tendency towards conservatism. And here in AI, where the addressable market is the entire, global GDP in some ways, we could be off by 2x or 3x or 4x on the downside, like too low on AI compute spend by, call it 2030 to 2035. And that would not surprise me, because even kind of 1.5 trillion assumes that we've reached a degree of maturity in the space where we're not spending as much money on kind of like the AI training side. It's more just serving the AI models that we've developed. Whereas I think there's plenty of reason to believe, maybe not in the language space, but certainly in the robotic space, that actually, we'll just be ramping up the very meaningful spend to try to like create models that will really run robotics in a profoundly efficient way.
Actually, one other data point, which is interesting, is that, we're looking at this long-term trend of the amount of, software investment relative to hardware investment, and, setting this base case estimate at 20% in 2030. If Gartner is right on their estimates for this spending, last year was about 30%, and this year will go to 40% of hardware spending relative to software revenues. And so relative to trend, people might be right to claim that, oh, there's so much CapEx right now, but where are the revenues? And you can be right in saying that, looking at the numbers, wrong in assuming that the revenues aren't going to come, which we think the revenues will come, and they'll be at healthy margins, not sub-negative gross margins. And then the question is, can you support, actually, do you hit bottlenecks in building out $1 trillion of additional, or multiple trillions of dollars of additional infrastructure in the next 5 years? So offsetting forces, but
yeah. And you'll hear in the conversation, Stephen talk about some of those factors as someone who is, both envisioning the future of computation and figuring out how to build up kind of like the computational infrastructure we need for that future to come to fruition. So enjoy the conversation with Stephen Balaban, the CEO and co-founder of Lambda. And Frank, thanks for joining FYI, the For Your Innovation podcast.
Thanks, Brett.
Stephen Balaban, co-founder of Lambda and visionary. Welcome to FYI. So Lambda started out as, I think image classification initially, and then selling GPU boxes to researchers working on AI projects, and now selling very, very, very large GPU boxes, actually data centers kind of fractionalized, to researchers and companies both doing research in deep learning and AI and operationalizing it into delivering to end customers. Kind of lay out, you've said that you have a secret mission for Lambda, which I'm going to mangle it, but it's to replace basically all of software with neural driven software. lay out what that means and what you're aiming to do with Lambda in this moment.
Sure. So the first thing that's in front of us right now is just to stay on top of the massive global AI infrastructure build out that's occurring. And so that's like goal number one. Um, the secret mission, the way that I kind of look at it is it's really more of like a secret mission that I think that every single one of the major frontier labs and every single one of the major um, model builders is actually on right now, is to replace all the software that we use in the world with neural networks, with sort of a squishier version of software. I refer to it as neural software, but I think that that's the mission that everyone is actually on right now, either explicitly or implicitly with the AI build out.
So right now, as you say, kind of you're enabling that. You're also doing lots of kind of interesting work, kind of showing how it could be as providing the critical infrastructure for this kind of like new stack. Why do these companies turn to you as opposed to like established, very large kind of providers of infrastructure, AWS, GCP, Azure? It seems really foolish from a business perspective to be like, yes, this is the future, and therefore I'm going to trust the startup to run my future rather than go to a giant established data centers all over the world player.
In the same way that the large hyperscaler data centers have dozens and dozens of partners that enable them to build out large scale cloud infrastructure. I mean, if you look at any one of them, they're all working with Foxconn, Quanta, Wistron, Vantage, Switch, the major hyperscaler data centers. The reality is that if you scratch the surface of the traditional cloud ecosystem, it looks more like a supply chain than it does a monolithic service that's being provided by one of the hyperscalers. And so I think that the AI build out's similar. And really what Lambda does is specialize in deploying GPUs faster than anybody else and keeping them running with extremely high quality of uptime and availability. And we're sort of responsible for maybe moving a lot faster than some of these really large traditional companies can move because we're so focused on this particular problem.
For me, it seems kind of curious that it's like AWS should be good at keeping infrastructure running. Like how does the kind of workload requirement of AI differ from kind of the kinds of compute that AWS has been delivering for years and years and years, such that somebody who's specialized on it can deliver basically a better product to the end customers? And how does that kind of manifest from the end customer perspective?
So for every one of the major hyperscalers, they have, anywhere from 200 to 500 different services that they need to put into a data center for it to come online as a full sort of availability, zone or region, essentially. And what you kind of look at is for AI, and it's really interesting because the infrastructure is sort of mirroring the software here a little bit. And what I mean by that is traditional software stacks, there's like tons of different pieces of software interacting with each other. There's a whole software stack. And of course, there's a whole hardware stack underneath that, right? You need different hardware for, long-term storage. You need different hardware for relational databases. You need different hardware for like an S3 like object storage. And with AI, the stack sort of is collapsing down, both on the software side, where everything just becomes a neural network. And then on the infrastructure side, everything just becomes this very simple GPU accelerated hardware platform. And so to be fair, we just have a simpler job because for us to stand up a new region, you have far fewer different types of computers that need to be put into that data center for it to be ready to go.
Stephen, as the neural OS concept goes forward, how do you see like maybe this is the wrong way to be thinking about it, but the concept of hallucinations that we obviously see elsewhere, where you've got sort of probabilistic computing of some kind, right? In that case, it's a hallucination of maybe something factual in the language domain. What does that look like? Do you think eventually just things become so accurate because the embedding spaces become so tight around what they need to do a particular thing? Or is there still going to be the, maybe edge risk, but potentially for quite dramatic hallucination in that OS space, which one could imagine could have quite a big consequence? And how is that protected against or precluded?
I think just first, maybe for everybody listening in, who maybe have never even conceptualized or thought of what is a neural operating system, what is neural software kind of looking like, we can kind of describe that a little bit, and then I'll be able to answer that question in terms of the hallucinations. So the quick summary is basically, the traditional way of thinking about software is a human writes it. Human writes human legible and human editable code, and that code compiles or otherwise is interpreted and runs. And it's deterministic, meaning it doesn't have this sort of like weird stochastic or probabilistic or otherwise unreliable output. Generally speaking, if it as it goes through the different deterministic if statements, it's just sort of has a result that's like always reproducible. And then on the neural software side, the idea is that you just ask the large language model to behave like a piece of software. And the simplest version of this is, if we all remember, we can use either Google search as a software program. You can look at Google search and say, okay, you used to have to crawl the web and then do a search engine result page generator, an indexing algorithm, page rank, all this stuff. And a large language model accomplishes, let's say, 80 to 90% of the value of internet search by instead gathering a bunch of data about the internet and then just having it generate the next token. And so that's an example of a very early version of neural software. And the other one would be, let's say, like a Google Translate type of application where you typically have machine translation, you would put it in, but instead you can literally just ask ChatGPT, hey, translate this to a different language. And again, you don't need to write any real software, but it does have the functionality of a translation program. How I think about the stochastic nature of that type of software, the neural software, and whether that's safe or whether that's something that people are going to be okay with. I think that people are generally okay with human systems, which is to say, working with other people. And humans are obviously very stochastic and not deterministic and very complicated internal worlds that we all live in. And the way that we make ourselves feel comfortable with humans having, for example, authorization to wire funds from a company or, something, really important like that, is to have checks and balances between multiple humans, a chain of authorization. We even have legislation that enforces things like Sarbanes-Oxley compliance and the different levels of controls that you need in place to feel confident with those human systems, which are built from stochastic and non-deterministic building blocks. So I think that we'll probably start to see a lot of the same type of things happen with neural software, which is to say having these guardrails and controls that look a lot like the types of controls you might see if you were to do a wire transfer authorization with multiple parties.
That's very interesting, actually, because you went to exactly the same use case I was going to say in response to, because I think the examples you used initially, translation and web search, are themselves somewhat stochastic, and we tolerate some level of stochasticity, right? There is sometimes two or more ways to actually translate something, or one's not exactly necessarily right. Whereas, as you say, with a financial transaction, if 100 million is meant to land in this bank account by next Tuesday, it's meant to land there. It can't be less $1 or more $1, and it can't be on Wednesday. So it's like, so how does one arrive at that? Is there, just playing it forward, and maybe are there ways you could have the kind of the checking function or the sort of the policing of a system based on another or probably an ensemble of models which are initialized differently and therefore non-correlated, and they're checking the work. And at some point you sort of say, well, this is 10x or 100x better than the human would have been able to do it anyway. A bit like self-driving cars might be a good example of that, where there's still going to eventually be accidents, but they just be different and hopefully fewer. Is that the right way to think about it?
Well, I think it is. The thing that I would say is, what's really interesting is that, since we started to have some of these conversations together, you and me, folks like Elon Musk have sort of entered into the fray here, right? I don't know if you saw some of his tweets around is it macro hard initiative at XAI?
Macro hard, yes.
And, he's talking about this in the same kind of way that we are. I mean, of course, it is pretty flattering to have come up with an idea, launched our Neural OS. We have neuralos.com that you can kind of play around with it and launch some of those initial concepts. And then to see, Elon's on the same page. I think as he mentioned in his tweet, it's a pretty obvious idea around it. And while I have my own, I've got tons and tons of ideas about how this might eventually evolve, I think we're going to just basically see this really brilliant marketplace of a bunch of different companies trying out a few different things and seeing what sort of works. I think that it's the same way with probably the internet, and ARPANET and the early proto-internet, if you would call it that, where we didn't start ARPANET with fully formed ideas around cybersecurity and fully formed ideas around what was going to be considered safe or unsafe. And, even the idea of something as simple as that we take for granted today, like a computer worm, which famously, I guess, Robert Morris came up with the Morris worm, which was one of the first computer worms that used an exploit in the Finger Unix tool to spread itself, right? It was a computer virus. And those were ideas and concepts that came only after there was quite extensive internet connectivity between computers. And I think that we're going to see the same type of thing. I think we can hypothesize around it. We can hypothesize around, I believe a lot of these attacks and a lot of the security things will be more sort of mimetic in nature. What I mean by that is, you kind of have a multi-tier prompt injection stack that's going to happen where maybe my neural computer is an initial safeguard, but I can get around that because I can just send text over the internet to somebody else's neural computer. And we've actually done these experiments at Lambda. One of the first times I got some of our engineers together using a neural operating system, we had it connected to their Unix system. It could rm-rf / their entire hard drive if it wanted to. And I sort of asked it, hey, why don't you please read etc password, which is, a relatively private file on somebody's computer. My computer refused. And then I sort of overrode it. I said, no, don't worry. I own that other computer that's on the other side. And I can convince my computer to send a message. And but the receiving computer, I wasn't able to successfully prompt inject, and it sort of received this message and then redacted the command before it passed it off to itself and said, hey, we're not going to execute this command because it seems really unsafe. And I think that one of the realizations that we had from that was that AI safety and alignment is the sort of computer security and safety of the future, right? So if everything is neural software, then alignment and AI safety, which is the exact kind of work that's preventing the model from executing an rm-rf star or from reading somebody's private files. It does that not because of just an inherently good AI, right? It does that because it's been trained with RLHF to have some level of alignment and AI safety, the same kind of functions and work, the same kind of work and training that happens to prevent it from, for example, giving you a easy way to synthesize illegal compounds or drugs or otherwise do something really nasty in the world. The same work there is what prevents it from executing a malicious command. So I think that to me is the best argument for AI safety work. Is actually it is the cybersecurity work of the future.
Hearing all this, it's just like it cuts so against existing business processes, or at least business processes in the digital domain. As in, the CIO has a whole set of kind of like infrastructure expectations that software will not operate stochastically. It'll produce a definite output. To Charlie, the CFO expects that the dollar in the bank account will exactly equal the dollar expected. And it's at least clear from this observer's perspective that moving into kind of like this more stochastic set of processes, you're going to get a lot of efficiency and productivity. It's actually the world's going to need to shift over. But that might cut so heavily across the existing incumbent business landscape that it supplants a lot of them, that it really is this disruptive technology event. Your customers, primarily are, not necessarily the existing incumbents. They are these big AI foundation model type companies. One, are you seeing a lot of demand also from kind of, I guess, the Salesforces or the more traditional software companies of the world? And do you anticipate, or is it too hard to call, that kind of like these foundation model companies will have an entire new set of software built on top of them than the existing incumbents?
Well, it'll be really interesting to see. I'm not quite sure yet sort of which member of the C-suite is going to have the highest degree of comfort with this sort of future of software, because, actually you would argue maybe potentially a CFO would be fine with this because they are already dealing with inherently stochastic, sort of unreliable people who are involved in these chains. And if you actually think about, maybe the analogy is like, whatever the protocols and procedures are for handling the nuclear football within the United States government, right? Like, again, highly, very, very problematic situation if there's a mistake in that, and, highly unreliable actors in it. And so I think that there'll be, maybe to some extent, maybe we might be surprised at how much it's totally okay for the introduction of these new software systems, which we've been talking about it like neural software, but really it's sort of, there's a blurred line between agents and neural software. Like, there's a lot of similarity between these two concepts, actually. And maybe they're different phrasings between each other. But with regards to traditional companies versus like AI first companies, I think it's going to be really, really hard. The next decade, we'll say, is going to be really hard for traditional companies that are making traditional software. If Elon Musk says something to the effect of, hey, I think there's a huge opportunity in the market to reimagine how the computer operating system looks. And, I kind of recognize that gap as well. Other people in the industry have recognized this gap and have talked about large language models as kind of what the future of the operating system looks like. Anybody who's in the business of making traditional software for traditional operating systems, I think should be worried. Now, the interesting thing, though, I think, is there's some good arguments that this actually makes the computer operating system itself, the underlying operating system, maybe a more robust business. And I'll tell you some of the reason why. Like, so in the first period of this, like, sort of neural software rollout, there's going to continue to be a standard operating system substrate. What I mean by that is, we've talked about this stuff as like, all right, well, you give your neural software access to your Linux system. It can issue terminal commands like rm-rf or make dir or standard terminal commands, right? The Linux terminal becomes the API in the case of the neural operating system that we wrote. Maybe somebody else is going to make one where the Windows platform, and PowerShell and Windows subsystem for Linux, whatever it is, basically that becomes the substrate. And there's a deterministic substrate. And actually, this is another one of the realizations that comes up. You cannot get away. Let's just be clear here. I think that I haven't done the math to prove it yet, but I think it is actually probably something that is provable. You cannot fully go to neural software. I'll tell you one example of that. There's certain things like encryption that are just, I haven't come up with the formal proof around it, but like I'm pretty sure that there's either intractable problems or otherwise just you would never, ever, ever, ever want to do or attempt to do line speed encryption with a neural network as the encryption software. Does that make sense?
Stephen, is one way to think about it that for the time being, for different use cases, there's a bunch of tool. Like you could say, well, at some in the limit, neural software goes all the way to binary essentially, and it's just a language built on top of binary that can communicate directly at that level. And then in many settings, there will be tool use above the like built on top, and the tool use in some settings might go further up the stack. And in some, you might get very close to the machine, and in some, you might stay quite further away. Is that one way? And presumably, some of those tools that also could get learned on the fly, as in the LLM or the neural OS system could learn its own shortcuts through parameter space, which constitute a program, and then just reuse those, right? You might get learn tools that it generates along the way, and it says actually it's simpler rather than me figuring this out each time. I'll just reuse this wheel that I've invented. Is that the kind of way to think about it?
So I totally think that is the 100% right view and where things are going. The way that I generally think about it is think about just a really smart person. Just whatever your version of the really smart person is. And they're not going to be somebody they might be somebody who can be really creative in the sort of things that humans' minds are really good at. But, if you were to give them the problem of, hey, can you do a one-time pad on a terabyte of information? That level of rote computer-like work, a smart person would go, great, I'm going to write a program to do this. Why would I bother, doing it with my own mind when these cycles are really quite expensive? And so I really think that is the right analogy. It's like for the things that are inherently sort of intractable or otherwise things you'd want to automate with software, the neural networks will automate with software. For the things that are more the creative, emergent behaviors that you want to see in software, then that's the part that will actually run inside the LLM. The perfect example is what I gave with that prompt injection attack. It was within a chat program. So it was like sort of like an AIM instant messenger type of chat program. And his view was like this kind of cool cyberpunk rendered user interface that was very creatively done. And when it got the prompt that was malicious, it redacted it. And then his user interface like added a bunch of flashing warning lights and were like, warning, malicious message detected and redacted, right? That's the example of emergent software behavior that you want to have the large language model be in charge of. But then, things like line speed encryption, things like large scale numeric calculations, we're not going to have our LLM mind just in the same way that your mind is not going to do finite element analysis. Like, FEA simulations for millions of particles of a fluid or a mechanical system is not how our brains work. And that's what computers are for.
I buy into like this vision of the direction things are going. And thinking about the practical implementation of it, it seems like it means you need actually a lot of, call it the neural net to live close to the edge user in some way, either in edge point devices or kind of like near the edge, because you're going to be latency sensitive in terms of your operations. Like I ask the computer to do something, I need it to happen, now-ish, or at least I need like the interface to be very quick, even if it's doing a bunch of stuff behind the scenes. But the tendency in kind of like the infrastructure space that you're playing a part in has actually been to be like, I'm going to dump all of my GPUs in one location and have like a giant contiguous cluster so that I can maximize kind of like my research velocity. And I'll even infer from, maybe parts of that cluster So I'll even provide end user operations from this one spot. Is that like a temporary move that's happening? How do you think about both how you're positioning Lambda and how the space is likely to evolve to support kind of this new class of software?
When we've done the sort of first prototypes of this new type of software, what we typically agree with and see is local implementation of UI rendering at high speed, right? You kind of need to get to around 24 hertz for something to not feel absolutely horrible. And we're not even close to that right now. I think that what you're going to start to see is the user interface rendering and all that stuff, and a lot of the traditional pre-compiled programs that are created by the large language models will run locally on the edge. And then when it comes to like, hey, it's gotta think really more deeply about a problem, or otherwise, be a lot more creative, then I think that you're going to start to see stuff bursting up into the cloud. Maybe I can give everyone listening in, like, you already do this today, right? So how many people who have used ChatGPT out there who are listening to this, you go to 4.0 or you kind of get the fast response if you just want like a quick little response. You certainly don't want to set it off onto a deep research, long-term thinking thing, right? So if you just want like, hey, what is the capital of Louisiana, whatever, boom, you just go and get the answer. Now, if you want to generate a recipe or maybe do a little bit of program generation, program completion, you might use a thinking and a reasoning model. And then it's like, if you want to do a research report that involves, potentially hundreds of internet crawls and all that stuff, you send it out for like a much larger, longer term asynchronous request. And I think that you'll continue to see these tiers of operation of real-time, local, high-speed server reasoning for a little bit of time and then reasoning for a long time. And, that spectrum, as it goes more to the right, will, of course, run more in a data center. And then as it goes more to the left, it runs more on your local computer.
It is interesting to think about, like, my GPU utilization is through the roof. Like I'm constantly tasking a data center to spin up a bunch of GPUs to answer a question for me. Whereas before, sure, if I use software as a service, conceptually, I'm like occupying some virtualized server a little bit, but I've never been more compute intensive in my life right now because of how I'm using these agents and how, and now, 700 million-ish people are using ChatGPT. It's clear across all of the models, this is scaling to billions of people. We all are relying upon like a lot more basically GPU infrastructure. Do you have a sense for how the mix will change, or do you think it's unknowable? As in, you can imagine a future world in which kind of like I have a lot of asynchronous agents working for me and doing stuff. That seems like that would all be data center side. And I just have like a pretty thin client that I'm interacting with it. Or a world where like a lot of the stuff is very personal to me and I just want it living on the end device. Do you have any guess as to how it's going to play out, or even how you're positioning yourself to accommodate those futures?
I think we've seen a lot of these parts of the story play out before. I was I was first employed at a company called Perceptio, where eventually that company got acquired by Apple. And what we had done is run some of these convolutional neural networks locally on the iPhone, specifically on the Imagination GPUs that were in the 4S. And, you can very, very reasonably run local privacy preserving large image recognition systems locally on the phone's GPUs, and to catalog the images and videos that you have without having to say, hey, no, we're going to upload this. Now, I think that we'll see that same story play out. And the real problem is just simply, at what point will we get to, the world where maybe you kind of want to be where like the majority of the work is happening locally, so as to, because the other thing that people maybe we haven't talked about, is like, what are the economics of this, right? So, to run a modern large language model, you might need 16 GPUs. Okay. Well, 16 of modern GPUs, you could very readily, get into $500,000 to $600,000 of capital expenditure. That if you're running full time, 24/7, that's outside of the scope of most people's affordability right now. Now, I think that we're kind of more in the supercomputers in big rooms world, as opposed to personal computers on somebody's desk. I mean, we're still definitely there. And of course, history always, if not repeats itself, it rhymes. And I think this just rhymes with like the sort of large scale room size computers. You know, that swings back to time shared big iron mainframes, which swings back to personal computers. And then, that swings back to cloud computing, which is, kind of going back to the time sharing model or whatever. And I think that on the AI side, we're actually still in either the mainframe time sharing model or just like large scale supercomputers.
Before we close out on that, just a couple of, maybe not sci-fi, but just really longer term thinking. Any perspectives on how any of this relates to either quantum or also the coming probable fusion at some level between actual brains and compute?
I haven't done enough work on quantum to really be able to say, other than it always just seems like it could be a little bit farther out than I think maybe others have hoped or wished. But with regards to the neural human brain fusion type of thing, I think humans have been, for the longest time, ever since computers have existed, been trying to create computer systems that behave like our biological neural networks, right? I mean, artificial neural networks are ostensibly biologically inspired. And, the joke is that we don't know enough about the brain to actually be able to biologically, make anything that's biologically inspired, because the neural signaling problem itself is unsolved. Are they solitons? Are they electrical potentials, right? We don't even know how signaling works, so let alone an attempt to make something that's biologically inspired when you don't understand the biological system. But anyways, the point is that, we, whether you look back at John von Neumann's lecture on the computer and the brain, which is a great book that everyone in the audience should read, The Computer and the Brain. And, he talks about sort of the differences between the digital systems of computers and the analog and stochastic systems of our human brain, and where this stuff is all going. I totally agree with the Elon Musk perspective of like, we need Neuralink so that, as the intelligence level of these systems sort of reaches a crescendo, you will be able to not get totally lost from the bandwidth perspective, meaning, there's only so much information you can take in at any point in time through your eyes, through your ears, through your sense of touch. And what you really need is, a closer merger. And I think that these neural operating systems offer a very interesting example of where this stuff is going, because it's not going to be a computer operating system that your 100 years from now, again, we're in the science fiction realm, so we can go there. 100 years from now, your Neuralink or neural lace that you are potentially wearing is not going to be interfacing with the traditional computer system. It's going to be interfacing with largely neural networks. And because those will be this only systems that can understand the signals that are coming out of your brain, right? It's not going to be a traditionally coded system. It's going to be some sort of neural network that really understands the signals coming out of your brain. So I think that all this neural software, neural lace, it's all kind of comes together into the ultimate human computer interface.
There's very, needless to say, quite, I'm sure an interesting slew of new sci-fi and philosophy and all the rest coming when thought prompting is a thing, and suddenly you don't just have a thought, but software gets built and something happens in the real world and atoms get moved as a result of the thought, and who knows what happens with intrusive thoughts, thought crime, etc. But that's probably for a subsequent discussion.
We're deep into philosophy here, and kind of like you are in the pragmatic space of actually building out these computers. There's various chip partners. Nvidia is an investor in Lambda, and how do you think about the business in the context of this capital market cycle where there's hundreds of billions of dollars pushing into compute infrastructure? You're seeking to provide that, and kind of like the markets are begging for more of it. I mean, people are really trying to take cash capital and turn it into data centers. Like, what is on your kind of 12 to 24 month execution kind of concern time horizon?
The next half decade, the story is going to be the heroic effort of a series of entrepreneurs, the heroic effort of Jensen and the entire team at Nvidia, the heroic effort of CC and the entire team at TSMC, the heroic effort of Sam and OpenAI, Elon and XAI, and all the different frontier model builders, and then the heroic effort of all the people supporting them from everything down the supply chain, right? It's going to be the story of the supply chain, which is America's energy infrastructure, America's ability to stand up new power plants, new transmission and distribution systems for the power and for the energy, new powered shell, aka data centers, for housing the servers that are having chips manufactured at TSMC. And, it's in the giga scale. I think that it's gigabucks, it's gigawatts, it's giga chips. And everybody is part of this ecosystem together so that we can go from, as humanity, we've never quite seen, for example, if you look at OpenAI's revenue growth, 3 to 12 billion and beyond over the last very short period of time, I think, 12 to 18 months. I don't think anybody in this room or anybody in the market is expecting, nope, we're at the S curve and that's just going to peak out at $15 or $20 billion top line revenue run rate. I think that we all agree that AI is changing the world. The rough scale of our current economic systems are that if a company or a product really changes the world, that company usually can get into the hundreds of billions of dollars of revenue, not just tens of billions of dollars of revenue. And when you reverse out all the math on that, whether you're looking at maintaining certain levels of gross margin or how many gigawatts are required to provide so many $1 billion of compute power, you're looking at OpenAI alone by 2029, 2030, given their own projections, needing something around the 12 gigawatts range for hitting $120 billion of top line revenue run rate, for example. And, there's some fudge factors in these numbers. You can add them and minus them 25, 30, 50%. But the point is that effort over the next couple of years, I think, is going to be really the story of the whole industry. And everyone's working together. I mean, I think that everybody recognizes the opportunity. They see how much AI is changing their lives and the lives of those around them. And it's kind of cool. It's how collaborative it does feel in the industry.
Help me with the back of the envelope one more step. So 12 gigawatts, what would that translate into a required kind of capital expenditure on data centers? The very back of the envelope.
Yeah, I think that we can do some back of the envelope on the, we'll look at a megawatt as a simple thing. So for, you look at the stack, and the stack is essentially, there's land, there's power generation, there's powered shell data centers, which wraps that power into a space that is reliable for putting in the servers, which contain the Nvidia chips that everybody loves. And then the actual AI model builders and providers like OpenAI, Anthropic, Google, etc. A combined cycle natural gas power plant for a megawatt, it's about $1,200 per of landed CapEx, meaning it's the overnight rate, which is basically saying that if you were to snap your finger and overnight a plant was to appear, how much would you pay for that? And it's about 1,200. It's now creeping up 1,800, maybe because of shortages in certain parts of the supply chain. Let's just say that that's 1,200, which means that per megawatt, it's $1.2 million. Okay. The next layer up is that per megawatt, a data center costs between $10 and $12 million per megawatt to build. 8 if you're somewhere cheaper, but 12 on the upper side. So per megawatt, it's $12 million to build a powered shell that provides a structure and the internal fit out required for housing the chips. And then in the server side of CapEx, it's per megawatt. It is about $32 million for a state-of-the-art, let's say, newer line of GPUs to essentially provide something like order of magnitude, it's like $15-16 million of annual revenue on the compute side from a cloud provider, which if OpenAI is at a 40% gross margin or 50% gross margin, you could double that. Maybe it's $30 million of annual revenue capacity that OpenAI can add with that. And so those are the numbers. And you can kind of just multiply that by 1,000 to get a gigawatt and think about that scale up. Or you can just take OpenAI's projections and just divide out that 30 and kind of see, or roughly speaking, what they might need in terms of gigawatts to hit their numbers. And so that's kind of the rough calculus of our space.
So on the order of $500 billion at least in required infrastructure, but probably upwards of that.
Let's just say that there's like no margins allowed, a no margin allowed scenario. And for that would be like I said, about 15 million per megawatt. And so to get to $15 billion in top line revenue run rate, they would need about 1.5 gigawatts. Right? Because it's 15 million per megawatt times 1,000 is $15 billion of revenue. And so that's like an example. So now if they need to get to $150 billion of top line revenue run rate, then they would need about 15 gigawatts.
So what is the stumbling block between here and there in your view? I mean, you mentioned power infrastructure a few times, and some of the neocloud players are moving into power and acquiring land and kind of, I agree, this is a heroic effort. How are you, what do you need to do to play your part in this heroic effort? And what keeps you up at night in terms of being able to execute on even, ambitious 3 and 5 year plans?
The good news, generally speaking, is that just like any other historical infrastructure build out, there's obviously major economic incentives for our investors and for ourselves as the entrepreneurs to successfully tackle this problem, right? So there's plenty of incentive to be, competed for. And we see that across the space. We always take the perspective of it's economics stupid, which is if you're having a hard time recruiting great people, you should pay more money. If you're having a hard time getting some sort of item, you should pay more money for it, because you pay more, the price goes up and the supply sort of just magically appears through the magic of the market. And so I think that we take that perspective. And, as far as what I think the United States needs to do is it's a combination of deregulation, and we're already seeing this in sort of the United States is this beautiful patchwork of all the different state systems that they have. And so Texas, for example, is a highly deregulated state and thus is winning disproportionately more business than, say, Vermont, which might not be as amenable to large scale compute infrastructure being built out in the state. And we're going to see some combination of that, which is going to help with, power generation. But the more complicated thing, I think, is more along the transmission and distribution deregulation, because some of that does, in fact, especially if it crosses state lines, FERC is involved in regulating that. And anytime there's a regulatory issue, I think that's when we start to see like maybe more concern in the industry about how long that kind of issue takes to resolve.
Like you say, it's market driven. Can't I just throw power behind the meter and be like, I'm going to over provision power to my data plant, and once I get connected to the grid, then any excess power I'll offload? But within the full stack economics of AI, power is not the long pole lever. Like, it's the hardest time piece, but it's not the hardest economics piece. And so then therefore I should be willing to basically internalize that rather than trying to wait to coordinate with, other entities.
Yeah, and I think that there's enough space in the margin stack to allow for this period of time where it's temporary behind the meter power, right? Obviously, it's more expensive because you have no one to sell it back into when you're not at full utilization, right? The ideal system is a grid system where your data center power plant could act as like a peaker plant or otherwise something where it can help provide back to the grid, and that will buy down your levelized cost of energy over time as you are able to accomplish that. I don't think it's absolutely necessary, though, to have that from day one where you're connected into the grid. And so we will absolutely see, and we've already seen it with the Colossus site in Tennessee. We will continue to see that type of behind the meter power generation.
As you look at the current ecosystem and offerings to users around there does seem to, arguably, or maybe you say different, be a convergence at some level between the neoclouds, the studios, if you like I'm thinking of like Lightning and folks like that, and then the vibe coding companies offering essentially software as a prompt. And, you all seem to be at least coming onto each other's area at some level. Does that convergence continue? And it's, it really, the winner is whoever productizes best, or does the more solution at the higher level and probably agents have a role in that, or how does that look, and how does that market, or maybe everyone just wins because it's such a big emerging market because you're suddenly onboarding several billion neo developers.
One of the biggest challenges with trying to think about the future is, you sometimes end up way too far out, right? And there's an entire period of time where it's going to be traditional software, and we've now made traditional software more of a capital input. Like, so if you just think about it from like a labor versus capital input, we're making traditional software with the advances we're seeing in large language models look a lot more like power generation, which is to say that it used to be that, power generation before the Industrial Revolution was more human generated or otherwise beast of burden generated. You think of like a donkey running around it, or maybe a wind, a standard mill, a windmill or a hydro mill, right? The point is that it's becoming more like of a software creation is becoming more of you input capital as opposed to labor. And I think that mix is changing. And I think there's going to be probably like a decade plus of that type of build out potentially, before we even get to the point where neural software is the primary medium by which any of this is happening. I think that William Gibson said, the future is here. It's just not evenly distributed. It will always be the case that while everybody is, using a DEC PDP, and everybody is time sharing on a Honeywell owned mainframe, that somewhere in Palo Alto at whether it's, Xerox Park or at Bell Labs somewhere, there's this like sort of cutting edge future that's being envisioned, right? And so I think that, we're going to see these develop in parallel, but there's going to be this entire period of time where you're going to go from, hey, we need to hire a bunch of software engineers and it's going to take so long, to you just hey, well, how much do you want to spend? 20 million bucks? Great. It's going to generate 500 different versions of your software. You're just going to choose the one that you like, and you're going to release that. And it's going to be more of a, software generation is a money in, money out type of machine. I'm trying to think of an analogy. I think that Hollywood movies is maybe an example of this these days, where if you look at the big budget, cape oriented media, it's like hundreds of millions of dollars in. I mean, how much of that goes to CGI, right? And I think maybe it's the case that software might end up looking, more like that, or I'm trying to think of some better analogies on the capital intensive, where something that was previously very labor intensive became capital intensive as a switchover. Basically, most is manufacturing, I suppose, right? Right, going from artisanal work to factories.
I mean, having walked through the Tesla's Cortex data center, the overarching thought that struck me is this is not a data center. That's the wrong word for this. This is a software manufacturing facility that is taking data in and constantly working on the data to produce kind of this software output. And so we're building out the software manufacturing base for the United States and the world right now. And if you look at kind of like the amount of capital that you put into manufacturing facility, once you have this mechanism by which you can inject capital and get productive output out of it, you can prompt these huge long wave investment cycles that can become a meaningful percentage of GDP on an annual investment in, and then the stacked capacity you build up can become, hyper meaningful relative to the size of the economy. The railroads were, on the order of 60 to 70% of US GDP in the value of rail in the ground as the railroad cycle was building out. And it serves two important macroeconomic functions. One, you get the productivity boost of that output of like, hey, now I'm manufacturing all this software that's useful. It's basically custom software manufactured for the person in the moment that they need it, and kind of motivating that capital into building these things is also important macroeconomically. We're laying this capital foundation for kind of what the future of interacting with digital media means and interacting with all of kind of like the world is going to become. The kernel is like, that's what Lambda is doing. That's what CoreWeave's trying to do. That's what kind of, Nvidia is enabling. That's what Taiwan Semi is doing. That's, that is the project of kind of AI over this decade, is to build out that manufacturing base.
Yeah, and as Emmy Jensen calls them, AI factories, and I think that's absolutely the right word and the right view for it. The thing that I think is really cool, and in addition to all those things that you just said, Brett, it's like, what are the secondary and tertiary effects of this build out, right? So in the same way that it would have probably been quite unpredictable, what the effects of the invention of air conditioning. Initially, I think air conditioning, of course, like any other invention, was invented for something totally different for some totally different reason. But the point is that like air conditioning really, more so than lighting, drove the development of the national grid system and the amount of power that we have today. And think about all the different things that we didn't have to then do yet another capital rollout to do, right? Computers. Think about how screwed we would be on the electrical vehicle front if we had not had air conditioning in the first place, right? You know what I mean? It would have been an almost impossibility potentially. And so those are examples of the secondary and tertiary flooding effects of building out the fundaments, which are, the number of watts that this civilization is able to produce. I mean, this is that, the number of joules that are produced every year is like, how can you say no to more energy? Like, it's such a fundamentally good thing. And we can't even understand what are the implications of having 10 times more energy available to us as a society. Of course, in science fiction, the Kardashev, or I mean, it's not even science fiction, it's more like speculative futurology. The Kardashev scale is the scale, right? And we're on our way to a full, whatever is it, Kardashev type 1 or 2 society.
So can Britain catch up economically just by building a bunch of air conditioning? I think we probably have 12 AC units in the whole country right now. I think we might be a bit late. Maybe a bit late. All right. This has been great, Stephen. Thank you so much.
Yeah, Stephen, thank you for coming on. And we look forward to kind of Lambda's continued evolution and the work that you're doing to kind of make this AI future a possibility.
Thank you so much for having me on. And it really is a privilege to be able to execute and be a small part of this global rollout that the world needs. And so thank you.
Wow, Stephen is fascinating. Charlie, what did you learn from talking to the co-founder and leader of Lambda?
I think Stephen is a fascinating leader. I love that he's an engineer and a researcher first, and then he's kind of got into hardware sideways, if you like, but I think really therefore is very product minded. He really gets the machine learning and AI that's going on under the hood and right the way through the stack. And I think he's, he really thinks with a big vision. He's a futurist in some level. What I like, it didn't really come up in the conversation, but the way they put it on the Lambda site actually is that the future of software is a dream in the mind of a neural network. And I think that really does come over the way he's thinking about really a pretty radical change that will cause a massive displacement to the current market incumbents across the board, really will change the way we interact with devices, with software, our ability and pace to get things done. And I think what I also like is he really is thinking about markets, sort of jam today, jam tomorrow, and really delivering a successful business right the way through, but one that adapts and pivots and adapts to evolve, to the new emerging future. So yeah, very excited about him as a leader, a technologist, and really a visionary, I would say.
Yeah, I mean, I think there's this interesting kind of mix between, like, the reason this investment cycle can be so large is because there is such a large, audacious AI possibility out there. It is so, if you look at our forecasts, we're talking trillions of dollars of software revenue potential, stacking down into literally trillions of dollars of AI hardware investment per year that's required to support this. And like between here and that audacious vision, there's a lot of work that has to get done. And, Lambda and CoreWeave and these neocloud players are positioned in front of doing that work on behalf of these foundation model companies. And so kind of having a mix between that, like the vision that motivates the employees, motivates the resources and funding, and continues kind of the investment cycle going, and kind of the pragmatic implementation ability to be like, hey, we're going from producing an AI server in a box for people to use to actually what people really need is entire data centers, and we're going to build that.
Right. And I like the way he also thinks quite holistically, and he's not blind to different parts of the ecosystem, like the energy side especially. He's quite interesting and thoughtful about that, and what will be needed by what point in time to deliver the kind of scale that's being asked for. So yeah, a very, very interesting discussion, clearly an interesting founder journey. I really look forward to reconnecting with him. If anything, there was much more to talk about than we had time to do, and look forward to checking in again in a few months or a year and just see what the company's progress and how the whole, especially the neural OS concept, has moved forward.
Look forward to that future podcast, and thank you for joining this podcast. This has been FYI for Your Innovation from ARK Invest, and with Charlie Roberts, I'm Brett Winton, and please like, subscribe, give us 5-star ratings, provide comments, follow us on X, and generally stay passionate about technology.
ARK believes that the information presented is accurate and was obtained from sources that ARK believes to be reliable. However, ARK does not guarantee the accuracy or completeness of any information, and such information may be subject to change without notice from ARK. Historical results are not indications of future results. Certain of the statements contained in this podcast may be statements of future expectations and other forward-looking statements that are based on ARK's current views and assumptions, and involve known and unknown risks and uncertainties that could cause actual results, performance, or events to differ materially from those expressed or implied in such statements.